Okay, guys, good morning. Let's do this. We're going to be starting off equations this week. So, in your spirals, please copy this down. 1, 5. Okay, we should be finishing up pretty soon. Okay, we're going to solve equations with one variable. Make sure you know that. And we're going to solve equations with two variables. We're not going to do much. It's pretty basic today. A lot of basic math, adding, subtracting, stuff like that. Dividing a little bit here and there. I do want to comment that we do have grades for the progress reports this week. So you all need to make sure you get all your grades in. I was looking at Alex. A lot of y'all are missing assignments here or two. I'm going to give you to tomorrow to get them fixed. So I'll extend all the deadlines, but you need to have them done. You good? You need to have those assignments done. This is not I guess like an easy class. You do have homework a lot. You do have a lot of assignments. You do not have a chance to make up this grade. So if you get a bad grade, it stays in your transcript. So you need to make sure you do it right the first time. Progress reports come out this next week, so be ready. Okay, so here we go. We're going to solve equations with one variable, solve equations with two variables. Let's come out here, just jump into it. We need some notes today. Okay, mathematical statement that contains an algebraic expression and symbols is an open sentence. So an expression right here, it's open, has like really no value to it. A sentence that contains an equal sign is an equation. So do me a favor, write that down as far as this part that I circle. Okay, write that down, please. Make sure you know an equation has an equal sign. Expression does not have an equal sign. Okay, so here we go. Finding a value for a variable that makes a sentence true is called solving. So if we have something here and we find the answer and we put it in there and it makes it true, we're finding a solution. The replacement value is a solution. Moving on, get more, so we get practice, okay? A set of numbers from which replacements for a variable may be chosen is called a replacement set. A set is a collection of objects or numbers that are often shown using braces. Each object or number in the set is called an element or number. A solution set is a set of elements from the replacement set that makes an open sentence true. I'm trying to figure out the main stuff for you to write, okay? So let me see. I hate to make y'all write so much because I'm trying to hurry up. Okay, write all of that, I guess. Write everything there, right? Horrible. I guess all of this too. Jeez. Okay, so I said I'll cut some. It has these little things. You'll see them right now. Like the ones you'll see. Like this stuff right here. That's a set. copy this next step down too. Sorry about that. Sorry so much copying today. Okay, so let's come out here. So let's just start. Y'all got it, guys? I want to move up pretty soon. I'll go back and review all these words you wrote or read about. Okay, I'll move it up already. Let's do it. Okay, so just making sure, let's come back here and understand what we just kind of covered-ish. This is here an open expression, a sentence. This one here is an equation. Now, X's are numbers, guys, or letters, or whatever that, you can always change into something else. Like X, you can change it to a number 1, a number 2, a number 3. That's a variable, basically, it varies. Now, here there's one that works. You can plug in anything and you get an answer. You plug in one here, and it works because it gives you equals. It gives you the exact same thing that you want, the 13. So you come out here, you solve in a sentence, and then when you put it in there, you find it, that's a solution. Sometimes the solutions work, sometimes they don't. We want the ones that work. We want the solution for this one that works. It gives us a 13. Okay? Sometimes, and this is usually in the beginning of your test, they give you an equation like this, and then this is your set. You see it's in these braces. Each one of these is an element. Now you plug them into the equation, right? So this set is all the numbers that they want you to go ahead. Hopefully you understand what this is saying. And these are all equal to the number or the letter Q, the variable Q. So when Q is 2, I plug it in here to get a 2 for the Q. I get a 2 times a Q, no longer a Q, a 2, plus this. It gives me a false statement. What do you mean a false statement? Well, we want it to equal 13. We're saying from the very beginning, equal 13. When I do this one, I get what? 4 plus 5. So I get 9. Is 9 equal to 13? True or false? False. It's not the right solution. It's not the one we want. So then we come out here and it says, well, that one didn't work, but this is my solution set. Okay, we want to see which one would work. All these right here, which is the correct one? That's what we're trying to figure out. Okay. So several might work, 1 might work, 2 might work. In the situation that 2 didn't work, it's not in the solution set. That's like okay, these are the ones we replace with. So these are, sorry, my replacement set. And then we want the answer. When we get the answer, the one that's the solution, the one that's the correct one, should be in a solution set. 3, plug in a 3 here for the Q. False statement. What do you mean? What, 2 times 3? 6. 6 plus 5? No. 4. 2 times 4, 8. 8 plus 5, 13. True, that's the one we want. We want the true one. So that one works. That one doesn't work. That one doesn't work. The work's done first already. Now regarding that one, and all this madness, all this replacement set here, only the one that worked was my 4. So that one goes in my solution set. So whatever we say set-wise, you want it in these notations, brackets, braces. Okay. Now I'm not gonna. I don't really write them really good. All right. So you just say squiggly lines, braces, brackets, something to that effect. Okay. Hopefully that makes sense. Let me move up. Okay, so find the solution set. So they want you to find the correct answer, maybe one, two, or three different numbers work. You never know. The set in the situation has only a member of number 4. So regarding these, find the solution set for each equation if the replacement set is this one. Okay, let's try 1A. Try 1A, guys. Come on. Or at least copy 1A down and let's work on it. Okay, so let's look at that one real quick. In regards to this one, let's say, hey, these are your replacement sets. Plug it in there. See which one works. Let's just try it from the very beginning. M is no longer M. We're going to put a 0 there. Minus 7. Is that equal to 17? We're plugging in here that these are my M values, okay? I'm trying it when M is equal to 0, okay? What do I get here? A times 0 is 0, minus 7, is that equal to 17? Is a negative 7 equal to a 17? False. Now let's try it when M is equal to 1. 8 times 1 minus 7, is that equal to 17? That's 8 minus 7, is that equal to 17? No, not even close. 1, is that equal to 17? You know what? Do me a favor. That's false. And we're going to come in here. And when M is equal to 2, so we're going to go 8 minus, 8 times 2 minus 7, is that equal to 17? This one gives me what? 16 minus 7, is that equal to 17? That gives me 9. False. Ooh, great. Let me squeeze this one in here. 3. Okay, 8 times 3 minus 7 is equal to 17. 24 minus 7 is that equal to 17? Oh, actually that is. 17 is equal to 17. So the solution, we're going to put true here. Solution set. So the set of all solutions for this one is only going to be the number 3. Okay, there's my solution set. Okay, anybody have any questions there? If not, try 1B already. Okay, guys, let's get started on this one. Let's see. Should give me enough time, I think, at least do a couple. So make sure you know this is my equation, and I want to go ahead and use this replacement set to find my solution set. So I'm going to go with 28, and is that equal to a 4? A 4 times a 1 plus a 3 times a 0. Okay, so this gives me a 0. So I'm going to have 1 plus a 0 here times a 4. 1 plus a 0 is a 1 times a 4, which is now just a 4. So is 28 equal to 4? False. Okay? Now I come out here and go 28. Try the replacement over here. We're going to do this one when D is equal to 1 now. So we're going to go, is that 28 equal to a 4 times a 1 plus a 3 times a 1? Okay? Now we do this one. 3 times a 1 is a 3. 3, right? So 3 times 1, now we add that one to a 1. So we're going to go with a 4 here. 4 times 4. Is that equal to a 28? Is 28 equal to 16? False. Now we're going to go D when D is equal to a 2 now. Replacement set, we're going to come out here and say, well, let's try that 2. So we're going to come out here is 28 equal to a 4 times a 1 plus a 3 times a 2. This gives me a 6. 6 plus 1, 7. So 4, 28. Okay, is 28 equal to a 4 times a 7? Is that equal to a 28? I'm going to say true. Let's see if the other one works. So we're going to go here. 28 is equal to 4 times a 1 plus a 3 times a 3. That gives me a 9 plus 1, 10. So 4 is 28. Remember, this is what we're doing when D is equal to 3. This one gives me 28. Is that equal to a 40? And we're going to say false. Okay? So regarding that one, my solution set would be this part, and we'd put only the number 2. So the only solution would be 2. At least from that, what's it called? Solution set. I'm sorry. Replacement set. Going once, going twice. Make it lost there. Not too bad. Come on. Okay. Your science says let's move on, sir. Okay, moving on. So regarding this part real quick, this one says, hey, use your order of operations. What's my final answer? I'm not going to spend time doing this one, but it's pretty easy. My first step would be, please excuse my dear anxiety, exponents, subtraction, whatever you get here, divide, then add 6. Exponents, subtraction, divide, add, there. So the answer for that one would be D. So in case you get like this, do you see the difference, guys? This one, you don't have to go in and find the answer as far as which one works from the replacement set, because it's saying, hey, your answer is when you do this work. Your answer, T, is equal to whatever your answer is here. Let's move up. Okay, some equations have a unique solution. Other equations do not have a solution. So what this is saying is sometimes there's only one answer, and sometimes there's no answer. What? Yes, you got to be aware of that. Let's look at this one real quick. Solve each equation. Okay, so they're just giving you this one as an example here. Look what's going on here. How or what do I do here? Well, what I want to do is get my n unknown. Okay, these are very simple in the beginning. So basically, you want to do, I think they're going to usually, in these, give you math you can do before you actually wind up looking for your n. All right? When you actually come out here on the left-hand side, if you do please excuse my dear insanity, wouldn't you get all this stuff done here? Wouldn't you get a 16? And then minus 10, which gives you a 6. And then you have 7 minus 6, which would give you a 1 before you come out here and add that one. So regarding this one real quick, that's basically what they want you to do. Do the math, see what math you can do. So before you get anything and everything, you're like, oh, whatever I need to do, look, can I do any math? Yes, I can do all this math before I have to add an n. So try to do that like from now on. Look, I can do math to clean it up, make it easier for myself. Always check that first. Regarding the final thing right here would be that. How do I get this? What would make the statement true? What if this one was a 9? Okay. I think in 6th grade they did a couple easy ones for you. Okay. Let me just refresh your memory. This is the way I teach my students. So you got to kind of look at this. This is equal. This side here is equal to this side. If you think about it, it's actually saying that. So it's saying they're balanced. This right here is equal to this side. They're balanced. Now I'm going to show you this much. If I add an x here, this side will actually go down and get heavier. But if I add an x over here, well, then it would push down with the same weight and stay balanced. If I take away that x, well, what would happen? This side would go up, and then this would go down. But if I take away that x here, then it stays balanced. I can add anything. If I add a triangle, I added something to it, guys, it would go down. It's heavier. But if I added the triangle over here, well, then it would, same weight, go down, balance out. So when it comes to this part here, you want to kind of look at it like this. Okay, I want to conveniently, this is like a review, get the n alone. I want this n by itself. So what I'm going to add to this side, I'm going to add, you hear me, I'm putting it there, you don't see it. I'm going to add a -1 to it. Basically, I'm going to subtract one. If I added a -1 here, I'm going to add a -1 over here on this side. These would cancel out. I'm giving you with n. This was 10 minus 1. And there it is. Okay? So that's that part real quick. This one has a solution. That's, the book will try to show you some have a solution and some don't. Let's look at this one real quick. Okay, so if I can do math here, and I do this, distribution, cleaning up, all this stuff, look what happens in this madness, and all of this madness. Okay, you do your math, do whatever it takes. Okay, this is just an example. Look what this shows me here. How in the world could this be true? Think about what I'm showing you here. If I get 5n, and I add 6 to it, and I get the same 5n, and I add 7 to it, how could they be equal to each other? Can they be equal to each other? This one gives you an example of no solution. Okay, so I'm going to tell you this much. When we get to later on, I'll explain to you this one later on too. But when you get to a point like this, you want to get the variables to one side. And I was telling you, this side is equal to this side. You got to kind of look at them like that. I always look at them like this. This side is balanced, and this is a scale. They're equal to each other. I always want to get the variables to one side. So imagine if I were to come out here and subtract 5n. I'm adding the 5n. I'm adding a -5n here. I'm subtracting them. These will cancel out, leaving me with 6 is equal to 7. How in the world can 6 equal to 7? You can't. So in that situation, this one's no solution. This one's the solution set, guys, would be this. Empty. Nothing inside. There is no solution for this one. So please make sure you know that one. If you get something weird, okay, I'll give you another example. What if I get 3 is equal to a -3? Are those things equal? No, there'd be no solution. So let's go out here and try this madness real quick. Let's try 3a. Okay, first off, can you do any math? Let's look at all this stuff. Can I do math anywhere here? Oh, yeah, I can do this math here. Oh, I can do this math here. All right, okay, so on this left-hand side, what do I get here? Let me see. 22 plus m is equal to 5 minus 2. It's 5 minus 3, 2. Okay, so let's think about this one a while ago. All right, I said let's get the variables to one side. Okay, so I'm going to remember this class is after 7th grade and 8th grade algebra, so you should kind of know how to do this already, right? I'm going to do brief reviews, and I'll work with you, and I promise you'll get up to par. I always want to lower the number of less variables moved. Okay, so I'm looking at it like this. This side equal to this side. Okay, they're balanced here. This side is equal to this side. What I want to do is I want this m going to this side over here. I'm going to tell you how I do that. To this side, I'm going to go ahead and This is just FYI. I always put the opposite of what I see. I want them down here, so I'm going to put the opposite. Why? They cancel out. Okay, these will purposely cancel out. This one doesn't just by chance happen to be whatever I feel like putting. No, I do strategic moves to make this one cancel out. I put its opposite. And now I just add it up like a big old addition sign. Keep this stuff on this side, keep this stuff on that side. These cancel out. Now I'm going to put 22, now this is my equal sign, equals, if I have 2m and a minus 1m, what does that give me? And so m is equal to 22. So my solution set would be 22. Okay, hopefully you got that one. Was that not freaky? Well, let's look, just FYI. If this was M22, right? I'm going to put blue. Why didn't it come out as blue? Come on. That'll give us 44, right? And then what's 2 times 22? Well, isn't that 44 also? So it would work. Try this now real quick. Hurry, hurry, hurry. Okay, let's look at this madness. Ready? And regarding this one real quick, is there math I can do? Oh, yes, I can do this, and then I can do this. And here I can do this, and I can do that. All right, so let's do this one real quick. That gives me 32 times k. You see this times k? I'm just going to put it next to it. Plus 45 is equal to, what's 36 minus 432? K minus 10. Oh, whoa, 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 look at this. Many years of doing this, guys. You see the equal sign? If I see 2 things that are exactly the same on either side of the equal sign, cancel them out. Okay, they have to be on the opposite sides. Okay, why can you do that? I'll explain to you why. I always want to use this or move the smaller one, so I'll get rid of this one. But if it's the same thing as this one over here, they're both going to cancel out. And what does it leave me? It leaves me 45 is equal to a negative 10. What does that mean? It's 45 equal to a negative 10. Nope. Thank you so much, Tom. So you can put no. So what does that mean? No solution. No solution for you guys. That's it. I have a solution right now. Lunchtime. Christopher, you're missing an assignment, bro. You need to go back on Alex and get it done. What's up, Priscilla? Did it work? On the weekend?
No, it didn't.
What?
No, it didn't.
You're nice. She's smart. It's just maybe you're just having issues. Guys, the rest of y'all go to lunch already. Priscilla, what are we gonna do? You need to find something soon, otherwise we're gonna get. What? Did you check your updates if they were all updated? Yes. Okay. How about this? Show me your phone. What are you on right now? Are you on your phone or are you on a computer? Okay, can you turn on your camera and then you have the iPad, right? Maybe you can show me the iPad or you're on your phone and I can see what it's doing. Dominic, we'll see you, brother. Who's this one over here? Oh, that's me. Mándame.